Hello everyone, I am Kavidarshini, a second year computer science and engineering student from Shriram Engineering College. Today I am going to present my lab experiment on EM algorithm for Bayesian network under the subject Artificial Intelligence and Machine Learning. Aim. The main aim of this experiment is to implement the expectation maximization algorithm for Bayesian networks. This algorithm is mainly used to learn the parameters of a probabilistic model and to estimate hidden variables using the available observed data. It is especially useful when the dataset is incomplete or contain missing information. Introduction. Bayesian network are a type of probabilistic graphical model used to represent a set of variables and their conditional dependencies. In real world scenarios, not all variables are directly observable, so some of them remain hidden. To handle such situations, we use the EM algorithm, which helps in estimating both the hidden variable and the model parameters effectively. What is EM algorithm? The EM algorithm stands for expectation maximization. It is an iterative optimization technique used when the data contain hidden or missing values. The algorithm works in two main steps, the expectation step and the maximization step, which are repeated until the model converges to stable values. Initialization. In the initialization step, we begin by assigning initial value to the parameters of the Bayesian network. This includes defining the conditional probability distributions for each variable. These initial values can either be randomly assigned or based on prior knowledge depending on the problem. E-step. In the expectation step, the algorithm estimates the hidden variables using the current parameter values. It calculates the expected values of the missing data by computing posterior probabilities. This step essentially fills in the missing information in a probabilistic manner. M step. In the maximization step, the parameters of the model are updated using the values obtained from the E step. The goal here is to explain the expected log likelihood of the data. This step improves the accuracy of the model with each iteration. The E step and M step are repeated iteratively. This process continues until conversion is achieved, meaning the parameter values do not change significantly between iterations. At this point, the model is considered to be well trained. Bayesian network. In this example, the Bayesian network consists of three nodes CDS. There are directed edges from C to S and from D to S, which means that S is dependent on both C and D. This structure helps in understanding how variables influence each other. Program Part 1. In this part of the program, we import the necessary libraries such as pgmpy and numpy. Then we define the structure of the Bayesian network by specifying the relationship between variables using edges. Program Part 2. Here we define the conditional probability distribution for each variable using tabular CBD. This distribution represents the probability of each variable given its parent nodes. After defining them, we add this CPDS to the model. Program Part 3. In this step, we generate sample data using NumPy. Then we apply maximum likelihood estimation to train the model using the generated data set. This helps in estimating the parameters based on observed data. Inference. In this step, we perform inference using the variable elimination method. We query the probability distribution of variable S given some evidence such as the value of C. This helps in making predictions based on the model. Output. This slide shows the output of the inference query. It provides the probability values for different states of variable S. This result indicates how likely each outcome is based on the given evidence. Conclusion. In conclusion, the EM algorithm is a powerful technique for handling incomplete data. It helps in learning model parameters and estimating hidden variables effectively. It is widely used in machine learning, artificial intelligence, and probabilistic model. Thank you for listening to my presentation.